screen here. Okay. Oh, I see. Somebody asked me in the chat, who is your favorite football player? Oh my goodness. My favorite football player. Okay, hold on. Before that, let me share my screen here. Okay. All right. So I hope everybody has this worksheet here. Let me see if we can connect. All right, that's great. Now I can see everyone as well. Okay, lovely. So over here, okay, I hope everyone has the worksheet. Or okay, let me just check in the chat again. So at the end, will the answers? Oh, okay, so who is your favorite? Oh, okay. So Dylan say he doesn't have it. Okay, I'm gonna send you in the chat the worksheet. Okay, and oh, interesting. I got some students from Peak Labs as well. Oh, okay. So Isaac Ram, I think you look very familiar. I think I've seen you, I think I've taught you before last time as well. Oh, interesting. Elena as well. I love watching Pilates and I think I saw you. You have seen me? Okay, that's interesting. So I guess if you guys recognize me, then maybe I'm quite popular. No, I'm kidding. Okay, anyway, so okay, one more question. Geet asked me, who is your favorite football player? My favorite football player will be, as of now, Declan Rice, because I support Arsenal. So hopefully we have some Arsenal fans in the in the call as well. Okay, if you are a Man U fan, go away because Man U recently won Arsenal. Oh no. Okay, anyways, another question. Ethan said, at the end, will the answers be given? The answers, we will be going through every single question actually. So as long as you guys write down your answers, okay, then yeah, I think you guys will have the answers with you lah. So yeah, that's that. Okay, and yeah, I would say if there's no other question, okay, by the way, questions, you guys can still continue to send it to me in the chat as well. If you guys want to unmute and ask me, also can. Okay, just make sure you guys don't randomly unmute and randomly say things. Okay, or Ethan say I have to leave early. Oh, I see. If you have to leave early, okay, I will try to get a hold of, maybe I'll get your mom's email or something. Maybe I can send her the answer key as well. All right, so yeah, no worries, Ethan. So okay, let's begin. Okay, let me open up. Okay, I think everyone can see the screen, right? So I hope everyone is able to see on the screen here. So we are going to take a look at the first chapter for today, which is on factors and multiples. So factors and multiples, I think is something that you guys had just started learning in Sec 1. Okay, but the thing is, in primary 4, you guys would have heard of the words factors, multiples, but now we are combining them together into factors and multiples. Okay, so over here, okay, on top of just factors and multiples, we also learn about this thing called prime numbers. Okay, so prime numbers, what are actually prime numbers? Okay, so these are numbers. Oh, by the way, if you guys have highlighters, please take out your highlighter and highlight together with me. So numbers that can only be divided by 1 or the number itself. So some examples of the prime numbers will be the numbers 2, 3, 5, 7, and 11. Okay, so these are some examples of prime numbers. And now let's take a look at the next one. Okay, we also have composite numbers. So what are composite numbers? So composite numbers are numbers with at least 2 or more factors. So highlight that with me, 2 or more factors. So example, when we talk about the number 4. Okay, so over here, all right, the number 4, if you guys didn't know, what are the factors of 4? Okay, I've got 1 times 4, and then I've got 2 times 2. So if you realize, over here, I have 2 or more factors actually. So I have more than 2 factors, which means it is not a prime number. So what do we consider, or what do we call these kind of numbers? These are composite numbers. And then obviously, I think in your schools, you guys would have learned about this thing called prime factorization. So what is prime factorization? Is when we try to express the numbers, okay, in terms of the product of prime. So example over here, okay, we can express 17640 into 2 cubed times 3 squared times 5 times 7. Okay, so now for me, right, I like to ask my students questions as well. So let me see who is the lucky individual right now. Okay, let's see. The first name I see here is Chin Feng. So Chin Feng, are you there, Chin Feng? So Chin Feng, can you tell me? Okay, it's a simple question, very simple question. So Chin Feng, what is one of the method that your teachers taught you in school in terms of how to do prime factorization? So I think your teachers would have taught you something like a particular method. So Chin Feng, can you tell me what is this method that you've been taught in school? Okay, Chin Feng, are you there? Okay, if Chin Feng is not there, never mind. Then I will ask the other student. Oh, Chin Feng messaged me. Oh, Chin Feng said table method. Very good. Okay, it's called the table method. Or I think the other one which a lot of teachers go through in school is called the ladder method. Okay, so over here I'm gonna write down. Okay, we can use the ladder method. Okay, so there's the ladder method, and then there's also using the calculator. So you can use a calculator as to, I would say, calculate out the different, what's it called, prime factorization as well. Okay, so using the calculator, I would say, is the easiest method to find out your prime factorization. Oh, Jared say use the brain cells. You're not wrong. You also have to use the brain cells. You know, on top of all this, you must also use brain cells. Then you can do the question. So good job, Jared. Thanks for letting me know. So, a typical type of question. Okay, for example, we have this questions over here. So you can see A is 2 squared times 3 power 4 times 7 squared. B is equals to 3 squared times 5 times 7 squared. And C equals to 2 cubed times 3 to the power of 12 times 5 to the power of 6. So over here, okay, a commonly asked question is that they'll ask you to find the HCF, LCM, and when it comes to HCF and LCM, there is a trick, if you guys didn't know, okay, to find out the HCF and LCM. So for HCF, we have to find we choose the smallest power. Okay, so for example, when we want to find out the HCF of A and B, okay, we take a look at the top, A and B over here. So I will choose the smallest power. So when we compare, right, okay, the thing is, when I compare, I must make sure the numbers that I compare is the same number lah. For example, okay, when I take a look at 2 square and at the bottom, B over here, I don't see any power 2. I mean, I don't see any base number 2 here. So what I'm going to do is I will include a 2 to the power of 0. Because if you guys don't, I would say you guys may be wondering, huh? Mr. Hassan, why is it that, oh wait, some of you guys say not done yet. Okay, Lucas, not done yet, is it? Okay, I'll quickly give you a bit of time to copy the one on top. Okay, I'll give you about 10 seconds and should be enough time to copy down. And yeah, I'll scroll down again. So now, when I write in 2 power 0, if you type into your calculator, right? Okay, if you have a calculator, please take it out as well. 2 to the power of 0. You'll realize that in your calculator, you will get the number 1. So 2 power 0 is the same as 1, which means when I add or when I try to choose my hits here, and then at the top I realize, on top got 2 square. At the bottom here for B, I don't see any power 2, or I don't see any base number 2. So what I'm going to do is I will add or multiply a 2 power 0. So when I multiply a 2 power 0, this time, when I compare the base number 2, now it's more obvious. Which power do I choose? I actually choose 2 to the power of 0 because it is the smaller power. Okay, so I will choose 2 power 0. But I know some of you guys may be wondering, hey, Mr. Hassan, you scam me. Why? Why I scam you? Because in the answer don't have 2 power 0. Why do I have 2 power 0? It's because 2 power 0 is just the same as 1. So teachers in the school, they don't usually write down 2 power 0. But when we continue to compare the different base numbers here, so when I take a look at 3 power 4 and 3 squared, okay, so we realize that the smaller power will be 3 power 2. Okay, so I write down 3 power 2 here. And then I will do the same thing with 5. And then once again, alamak, at the bottom got 5, guys. But on top don't have 5 for A. So this means that I will multiply with 5 power 0. So once again, I will compare between 5 and 5 power 0. So now you guys might be wondering, 5 don't have any power, Mr. Hassan, so I cannot compare. Don't forget, 5 actually has an invincible power. Not the power has superpower. The power over here, has a power of 1. So when we compare 1 with 0, which one is the smaller power? It will be 5 power 0. So once again, maybe some of you guys may be wondering, hey, Mr. Hassan, over here don't have 2 power 0 and 5 power 0, right? So why is it that I choose the 5 power 0? It's because 5 power 0 equals to 1. Okay, and similarly, when I compare the 7 this time, 7 square and 7 square, which one is smaller? They are both equally small. So I don't need to, figure out which is the smaller one. So I can choose any one over here. So in my final answer, okay, it will be the one over here. Okay, so Alina, yes, you raised your hand. Is there a reason why you raised your hand? Or you accidentally press it? So if you raise your hand, you can unmute and ask me, or maybe you can type it in the chat as well. Okay, so that is the idea behind finding HCF, and for LCM, it's the same idea as well. Okay, so over here, okay, when we take a look at LCM, LCM is when I choose the highest power. So it's the opposite of HCF over here. Okay, then of course, we also have questions that ask you to calculate the square of certain powers. For example, when the question asks you to find A squared, what I'm doing here is I'm taking the powers of A. So over here, I got power number 2, power number 4, power number 2. So I will just multiply it with 2 to become 4, 8, and 4 over here. All right, so if you guys still don't understand, don't worry. We are going to be doing some practices after this as well. Okay, so over here, okay, we will continue on to, like, I'm just going through a quick summary, and then when we are practicing together, then you guys can understand more on what I'm doing. So okay, Alina said that teacher, when it's on Google Docs, it won't show the algebra letters and equal signs. It shows A in a black diamond instead. Okay, then maybe don't leave it in Google Docs. I think you need to export it as a PDF first. Do it on paper, then yes, please. Yes, like what Lucas said. So you can have this on your screen, and then maybe on your paper, you write down your working lah. I think that will be doable as well. Okay, so yes, that should be able to help you guys out as well. Okay, so let's take a look at the next one. Okay, so a commonly tested question over here as well is where they will give you AK. Okay, and then your job is to find out what is the value of K. So when we find out or when the question asks you about, how to find the value of K, all you need to do is to round out the powers to the nearest multiple of 2. Okay, so I'm not sure if your teachers in school would have mentioned this to you. So I would say if they did, then good, they remember. But if they didn't, then this is a good trick. Okay, so later on we'll be going through this as well. So please remember this. And then for A over K, it's just the opposite. We are rounding down the powers to the nearest multiples of 2. Okay, and that's for square. And then for cube, it's just the fact that it will be multiples of 3 instead. Okay, so now I hope you guys can read okay, Vincent said can sell the file again. Okay, yes, I can send it to you over here. All right, so let's take a look at question number 1 here. Okay, so this is a very commonly tested question that I've seen so many times coming out for a lot of WA1s. Okay, so if you guys, I would say, remember how to do this kind of question, I think it'll be really useful for you guys. Okay, so let's take a look at the questions together over here. Okay, so I've got question 1 here. They say written as a product of its prime factors. Okay, 12 equals to 2 squared times 3. Write 144 as a product of its prime factors. So for me, what I usually do for this kind of question is I will use my calculator. Okay, take out your calculators with you if you guys have your calculators. So remember, I need to find out a way to express 144 in terms of the factors over here. So we can only divide it with prime numbers. So what are the prime numbers that we know? It will be 2, 3, 5, 7, 11, 13. Okay, there's plenty of prime numbers as well. So you guys can work accordingly. So yes, Dylan say easy. I know, right? A super easy one. So over here, I'll just take 144. So in my calculator, what I'm going to do is I'm going to take 144 and then divide by 2. And then I realized, oh, I get 72 over here. So if I get 72, what do you guys think? Can I still divide it by 2? Yes, right? So instead of dividing it by 2, I will divide it by 2 squared. So I'll just put it to 2 squared. Then I realized, I get 36 still. I still get a whole number. So I will divide it by 2 cubed. So I keep increasing the power until I hit a point where my number becomes a fraction. So when my number becomes a fraction, then I would say you can't divide it by the number already. So example, when I try 2 divide by 4, okay, still can. 2 divide by 144 divide by 2 power 5. Oh yo, I get a fraction there, guys. So this means that I can only divide it by 2 power 4. So I'll write down 2 power 4 here. And then I realize, divide by 2 power 4 and I get 9. So what other numbers can I divide over here? So I'll write down 144 divide by 2 power 4, divide by 3. Okay, now that's okay. I still, yes, yeah, Dylan also just said 3. Correct. So I can divide it by 3. And then once again, I divide it by 3 square. And then yes. So in your calculator, when you type it out, you are able to get the number 1 eventually. So this means that my answer will be 2 power 4 times 3 squared. So this is one of the ways. If you guys want to use the other method, I think the method that your teachers taught you in school, which is to use the ladder method or the table method. Okay, so you write down 144, and then what you're going to do is you divide by 2, and then you get 72. Then you divide by 2, you get 36. Divide by 2, you get 18. Divide by 2, you get 9. Then you divide by 3, divide by 3. And then you'll get 1. So this method is also possible. Okay, so part 1, very easy peasy. I hope everyone can follow as well. And let's take a look at part 2. So now, this is where they ask to find the HCF of two numbers. Okay, they say over here the HCF of two numbers is 12. The lowest common multiple of the two numbers is 144. Both numbers are greater than 20. So find the two numbers. So for this question, I would say it's quite different. Okay, they ask us over here that the HCF of the two numbers is 12. So let's just write down that the HCF, okay, over here is 12, right? So it's 12, which equals to 2 squared times 3. Then how about the LCM? Okay, LCM, on the other hand, okay, is equivalent to 144, right? So 144, which equals to 2 power 4 times 3 squared. Okay, so now that I have these two already, so now the question actually told us the HCF and LCM, and we have to find what the two numbers are. So now, whenever we choose our HCF, okay, what do we need to do? We need to choose the smaller number. So over here, let's take a look. Okay, let's say our first number. Okay, let me just write now, first number and the second number. So I don't know exactly what these two numbers are, but all I know is that when I choose or when I find out my HCF and LCM, I get these two values over here, which is 12 and 144. So 12 and 144. So maybe I can ask, who else is here? Oh, Isaac. Isaac, if I want to find the HCF, right, Isaac, do I choose the smallest power or the largest power? What do you think, Isaac? So highest common factor. So if you forgot already, take a look at the notes on top. Over here. Yes, correct. Isaac said the smallest power. So the thing is, right, when I take a look at my two HCF and LCF, my HCF over here, okay, I chose the smallest power. So when I choose the smallest power, I have 2 square over here. So this 2 square must come from a number. So what is the number, or which number it came from? Let's just say it came from the first number. Okay, then now the lowest power, yes, correct, the lowest power, Leland. So I know that, okay, the 2 square came from one of the numbers, which is, let's say, the first number. Now, how about this 2 power 4? So this 2 power 4 over here, if you take a look, okay, it must have, like LCM is the opposite of HCF. So if HCF, we choose the smallest power, LCM, we choose the largest power. So over here, if I know my first number is 2 square, okay, this means that when I'm choosing my LCM, right, it should be the largest power. So this tells me that my LCM must have come from my second number. And we're going to do the same thing for the number 3 over here. So next number will be 3. So this 3 is the HCF, correct? So HCF means I choose the smallest power. So where should the smallest power come from? Possibly the first number, right? Okay, so I'll write that down. So first power is times 3. Then maybe for the second one, the 3 square. Okay, maybe it came from the second number. So now, let's double check. Okay, our first number, what? 3 square times 3. No, 2 square times 3. Ayo, this one over here equals to 12. But the problem here is, in the question, they said that both numbers are greater than 20. So this first number doesn't add up already. I can't have my numbers being here because this number is too small. So what I'm going to do is, I will try to switch around the numbers. So instead of the 3 being from, remember this 3 here, right? We say that, oh, this 3, maybe it was chosen from the first number. Let's try to bring the 3 to the second number. So I'm going to write down over here, okay, that the 3 is from the one at the bottom. And maybe the 3 square is the one on top. So now let's double check. Okay, 3 square times 2 square, that gets me 36. And 2 to the power of 4 times 3 gets me 48. Aha! Both my numbers are actually more than 20, which was the criteria given in the question. And now, when I try to find the HCF and LCM of these two numbers, I will still get these two numbers on top as well, which means my two numbers will be these two numbers over here. Okay, so for this kind of question, I would say it's a bit different than the ones that you see in your exams, which is why this kind of WA1 online revision is very useful, because we expose you to slightly more different kind of questions, okay, that you guys can be tested on in your exams as well. Okay, so that's for part 2. Let's take a look at part 3. So over here, they say that written as a product of its prime factors, 784 equals to 2 power 4 times 7 squared. So they say that the number 784 divided by P over Q is a perfect cube. So where P and Q are prime numbers, find the value of P and the value of Q. Okay, so Vincent say, can it be 2 to the power of 2 swapped with 2 to the power of 4? Oh, let's see. 2 to the power of 2 and 2 power of 4. So example earlier, 2 to the power of 4 on top, 2 to the power of 2 at the bottom. So then it will be 3 square and 3. So let's double check. 2 power 4 times 3 and 2 power 2 times 3 square. Yep, I guess that those is possible as well. So there's a few combinations over here. So yes, as long as, so the criteria is, as long as eventually my numbers are greater than 20. That's all that matters. Okay, so yeah, that's for this portion over here. Okay, next up, let's take a look at this one here. So the number 784 divided by P over Q is a perfect cube. Okay, where P and Q are prime numbers. So let's take a look at that. Okay, let's highlight that first. So if you guys have your highlighters, please highlight with me as well. Prime numbers. So just remember, prime numbers means they must be what's it called 2, 3, 5, 7, and 9. So over here they say that the number 784 divided by P over Q is a perfect cube. So when you see this portion here, this is where I would say it gets a bit tricky, because the question purposely put a division over here. So whenever we see division last time in primary school, I would say, I'm not sure if your teacher say this, but try to change from a division into a multiplication, because multiplication is something that you can deal with a lot easier. So 784, okay, divide by P over Q, okay, is the same as, if you guys remember last time in primary 6, I think your teachers got tell you the keep, change, flip. Okay, so when they say keep, change, flip, means what? I have to keep the first number the same. I change the divide into multiply, and then I will flip the Q over P like that. Okay, so that is how we do the keep, change, flip. Okay, so now, okay, they say that they want it to be a perfect cube. So maybe I can ask Geraldine, if you're there, can you let me know? You can just let me know in the chat as well. So when it is a perfect cube, right? What is it that your teachers see in school? The powers must have. The powers must be a multiple of something. Do you know what they must be a multiple of, Geraldine? So let's see what Geraldine says. Even, even is not correct. Multiples of 3. Correct, Geraldine. So over here, I want you guys to write down that it must be multiples of 3. Okay, so yes, correct. Multiples of 3. Good. So for it to be multiples of 3, okay, over here, all right, we will take a look at the one at the bottom here. So I know that the powers must be multiples of 3, right? So since they already told us that 784 equals to 2 power 4 times 7 squared. So let's just rewrite this down. 2 to the power of 4 times 7 squared times Q over P. So if I were to combine all of this together into one fraction, how will this look like? So 2 power 4 times 7 squared times Q over P like that. Okay, so now this is where I will start asking you guys to take a look at the powers. Guys, are the powers over here multiples of 3? I think you guys can quickly tell me, right? Yeah, Mr. Hassan. Yeah, so easy. Of course, it's not power 3 lah. You take a look. Over here is, they are all not multiples of 3. One is 4, then another one is 2. Then how, guys? So this is where P and Q comes in. So P and Q, what they will do is that they will help you change the power into something that can be multiples of 3. So let's take a look at Q. Okay, what can Q do? So Q is being multiplied to 2 to the power of 4 and 7 squared. So let's see. Okay, let me just write down at the bottom here. So 2 to the power of 4 times 7 squared. So please remember, they say that the numbers must be prime numbers. Okay, and now let's take a look. So since I want them to be multiples of 3, so let's take a look at the numbers here. One is power 4, the other one is power 2. So maybe I can ask, who else have I not asked? Is it Git? Yes, Git. Can you tell me, Git? What number, right, should we change this power 4 into? What power should it be? So should it be, because we see that it must be multiples of 3. So it can be 3, it can be 6, it can be 9. So Git, what do you think? Okay, you say change 4 to 3. Okay, so we change 4 to 3 means I decrease this to the number 3. Okay, good. And then the 2, we change it to 3. Very good as well. So now, how do I change them? This is where I will have to, okay, I'll just make this a bit nicer for you guys to see. So this will be 7 power 3 and 2 power 4 become 2 power 3. Okay, let me change the color. And all right. So now, since I want my 2 power 4 become 2 power 3, so what am I doing? Am I increasing or decreasing? I'm decreasing, correct. So if I'm decreasing, this means that I am dividing it by 2. Okay, because it's just 2 power 4 to 2 power 3. So I just divide it by 2. But on the other hand, for 7 power 2, I'm multiplying it by 3. So similarly, we take a look at Q, we take a look at P. I think you guys can easily tell me. Yeah, he'd say that P is the remover, Q is the donor. Oh, okay, yeah, that's a good way to put it as well. Okay, because Q is the blood donor, P is the victim. Oh my goodness. I guess you're not wrong as well. It does seem like that, CNE. So over here, Q, like what you guys say, is the donor. It's trying to increase the value, right? Which means Q, okay, will be 7. Okay, then how about P? P is the one that is what's it called, decreasing in value. So P is taking away the what's it called, the value, which means P will equals to 2. Correct. Yeah, I see Dylan typing to me. Yes, it is correct. Oh my goodness, wow, George got a lot of smiley face. But yes, that is right. Okay, so anyways, so our value of P and Q will be as follows. Okay, so that is for question number 1. So I hope you guys can see the vibe that we're going for in class over here. Okay, so it's very chill. I hope you guys don't think it's super duper stressful or anything. Okay, it's supposed to be a recap on whatever that you guys have learned already. So if you guys had okay, so can it be 2 to the power of 6 and 7 to the power of 3? Okay. So when you do that, I would say it is possible, but then I think your numbers, right, it will not be a prime number. Okay, so for example, if we try to make 7 to the power of 3, then I will get 21. So 21, unfortunately, it's not a prime number. So example, 7 to the power of, wait, let me see, 7, can it be 2 to the power of 6 and 7 to the power of 3? 2 to the power of 6, oh, okay, that doesn't work because actually, we need to decrease one of the values. What you're doing is you are increasing both the values, okay, to a higher number. So that doesn't work. You need to increase one and then decrease the other. Okay, so I hope that explains it for you, Vincent. Okay, so yeah, because what you're doing is you want to increase both to 2 power 6. Yeah, one is 2 power 6, the other one is 7 power 3. However, this is not going to work because both of them are increasing in value. Okay, so that is that over here. And yeah, and also if you want to increase it to 2 power 6, right, you realize that what I said earlier. For it to increase, I must times 2 squared. And 2 squared is not a prime number. 2 squared is 4. 4 is not a prime number at all. So we cannot use the increment over here. So this one is not going to work. Okay, so yeah, but anyways, if there's any questions as well, you can also look for me at the end of class and I'll explain to you, okay? Because I know some of you guys may be a bit shy, scared to ask in front of everyone. So yeah, that is for this question over here. Okay, so now let's move on to question number 2. All right, so for question number two, wow, this question, I've seen it coming out so many times. And I hope that after today, you guys can definitely get these kind of questions correct one. Okay, I always see this question. So a gift shop uses 462 boxes of chocolates, 1,155 tins of cookies, and 693 bottles of wine to make as many gift hampers as possible. Each hamper has the same number of boxes of chocolates, bottles of wine, and tins of cookies. What is the greatest number of gift hampers that can be made? So over here, okay, maybe I can ask, okay, let me see, can I ask, who is next on my list here? Can I ask Ricky? So Ricky, can you tell me, Ricky, over here they ask, what is the greatest number of gift hampers that can be made? So, Ricky, what does greatest number actually mean? When you see the word greatest number of gift hampers, usually, I'm not sure if your teachers got tell you, right? You should already start thinking whether it's a HCF or an LCM. So what do you think, Ricky? Is it HCF or LCM? You see the words, what's that called? A greatest number. What do you think? Okay, oh, Elena said, is it I have to do prime factorization? Yes, you have to do prime factorization, you're not wrong. Okay, but let's see. Yes, Ricky, if you are there, maybe you can type out for me. Is it HCF or LCM? Oh, Aryan said HCF exclamation mark. And Jared keeps saying 77. Ayo, okay, guys, stop with the 77. Alamak. Oh, Lucas said H, correct. Okay, it is that. Okay, it is HCF. So whenever you see the words greatest number, greatest means is the highest. Highest means I would say is closely related to highest common factor. So HCF. And like what Elena said earlier, okay, she actually told me that, oh, isn't it to do prime factorization? Yes, do your prime factorization. Okay, so I'm not going to show you in detail what the prime factorization is because I think by now you guys are experts already. So I will just quickly write down the prime factorization of 462, 1155, and 693. Okay, so let's take a look over here. Okay, I have calculated for you guys. So for 462, it's 2 times 3 times 7 times 11. Okay, so let's double check that. Is it my calculator? 3 times 7 times 11, 462. And then 1155. Okay, when we do the prime factorization, it'll be 3 times 5 times 7 times 11. Okay, so let's double check that. Okay, yep, 1155. And for 693, it's 3 squared times 7 times 11. Okay, so 3 squared times 7 times 11, 693. Okay, great. Okay, so this is the prime factorization for each and every one of the numbers over here. So now, how do we find HCF? So earlier, I think we went through a bit, right? So at the top here, let me show you. HCF, we choose the smallest power. Okay, so let's choose the smallest power out of all the numbers over here. So let's start off with I'll just write down HCF equals to, okay, let's start off with the smallest possible number, right? So I'll just write down here, smallest power. Okay, so if it's the smallest power, let's take a look. Let's compare. 2 first, okay? 2, let's see, over here, let's compare the number 2. Ayo, guys, over here, right? If you guys didn't realize, only number 2 appears in the first what's called number. The others don't have any numbers, number 2. So what do we do? I think some of your teachers will tell you that, oh, if you don't see any other numbers, then you don't put the number. Correct as well. But I would say a trick just to, I think, to show that you understand is that if you don't see the number on top or you don't see the numbers at the other two, what we do is we will change or we will include something called the power 0 and power 0. So when I have the power 0, I can see some of you guys writing down the answer. Okay, good. Okay, yes, I think you guys got the correct answers as well. Okay, so over here, okay, I will take a look. I will add this 2 power 0. Now when I have 2 power 0, I do the comparison. So let's see. 2, which is power 1. Okay, over here 2 power 1 versus 2 power 0 versus 2 power 0. Which one is the smallest? 2 power 0, obviously, because it's 0, right? So it will be 2 power 0. So we're going to do the same thing for every single number. So the next number we're going to do is 3. So 3, 3, and 3 squared. The smallest power will be 3 power 1. Okay, so it's just 3. Next, I will do the same thing for 5. So let's see. 5, I have... ayo, 5 once again. I only got 5 in the middle one, guys. So how? So we'll do the same thing. If I only see one of the numbers, I will add the 5 on top and at the bottom. But what I'm going to do is I will times 5 power 0 times 5 power 0. And then when I have this 3 already, now I choose my smallest power, and my smallest power will be 5 power 0. And similarly, for the number 7, let's take a look. Okay, number 7 here, let me choose a different color. So 7, 7, and 7. Wow, so easy. It will just remain as 7. That's the smallest power. And lastly, for 11, I think 11 as well. Okay, I've got 11, 11, and 11. So it will just be 11 as well. Okay, so this is why HCF and LCM is super duper easy. Okay, so Ethan, oh, I think I saw somebody say something. So basically, it's 3 times 7 times 11. Very good, Justin. That is what it basically means. 3 times 7 times 11. Because remember, guys, 2 to the power of 0 equals to 1. 5 power 0 equals to 1. So that's why it will just be 3 times 7 times 11, which gives us an answer of 231. Okay, which I hope you guys were able to do. So why do we need to add the numbers with power 0? Okay, so the reason why I do that is because some students, when they see, let's say if I don't add the power 0, okay, they see this number here, right? Then they say, then they panic. And then you know what they do now, Aryan? They will just write down, oh, means I must times 5 here as well. Okay, so instead of panicking, right, what I usually tell my students is, okay, don't panic. You see over here got 5, right? On top and bottom don't have. So I will times a 5 power 0. Because when I times 5 power 0, is the same as just multiplying it by 1. So it doesn't change the value at all. So all you're doing is, when I add 5 power 0, 5 power 0, now you ask yourself, choose the smallest power. Okay, so when you choose the smallest power, it will still be 5 power 0. So that's why it's, what's it called? That's how I sort of help my students to better manage your stress during your exams as well. So yes, oh, that was me 5 seconds ago. I added 2 and 5. Yeah, see, that's the common mistake, correct? Okay, so that's why, thank you, Lucas, for showing me a great example of why I add this 5 power 0. Okay, because I think in school, the teachers sometimes they don't mention this, which I would say is quite scary because, you know, in exam, you're already stressing out, then you're wondering, where the 5 go to? Why only see 1 5 only? So this is where you add your own 5 as well. Okay, so that's for part A. Let's take a look at part B. So find the number of tins of cookies in each gift hamper. So, okay, by the way, I can see the chat is going a bit crazy as well. Okay, so guys, I'm gonna give you guys a warning now. Okay, before I disable the chat, please. Okay, I can see you guys are chatting here and there. Okay, that's good. But at the same time, please write down as well, because I cannot see whatever working. Don't later I hear from your parents tell me, oh, so and so, who is this? Oh, Justin never what's it called, do the paper. Okay, so please guys, do the papers as well. So how do we find the number of tins of cookies over here? Okay, so what I'm going to do is, since I know that there's going to be a total of 231 gift hampers, and in total I have how many tins of cookies? 1155. So all I need to do is to divide it with 231. And yes, some of you guys told me the answer already. It will be 5. Okay, so the answer is 5. All right. Oh, teacher, I always have problem with this part. Okay, so I assume you're talking about part B, is it, Elena? So if you're talking about part B, yes, this is a common question as well that comes out. Okay, so try to understand what it means when they say the number of tins of cookies. It means that they want you to find out how many cookies was being packed into each gift hamper. So since we already know, wow, in total got 231 gift hampers. So if I got all these cookies and I've got a certain amount of gift hampers, so I have to take the cookies, divide it among the gift hampers over here. All right, so that's for question number 2. Okay, so next up, question number 3. Okay, we've got a question over here that mentions about how there are 3 platforms on the over here. Yeah. Okay, so there are 3 platforms on the train station. Okay, oh, Git said, okay, all right, I can see you guys are discussing as well. Do prime factorization for both number together and then multiply the prime factors. You'll still get the same answer for part A, question 2 as well. Yes, correct. So yes, there are a few ways to get your answers. So don't be limited to just one method of solving as well. All right, so there are 3 platforms on the train station. The train enters the station, okay, and each platform at every 12 minutes, 21 minutes, and half an hour. The operating hours of the station is from 7:30 a.m. to 11 p.m. daily. Every morning, the trains on all platforms enters the same station at the same time at 7:30 a.m. how many more times in a day will the trains enter the station together? So over here, when question asks you to find out the same time, so example, over here you guys can highlight, okay, trains on all platforms enter the same station at the same time. So how many more times will they enter in the same day? So what they're trying to ask you, right, is they're trying to find out the common time where all these three trains will meet. So I want you guys to write that down over here. Okay, so this refers to the common time. Okay, so I think I got, let me see if I managed to write it down for you guys over here. Okay, so if I didn't realize, oh, okay, nice. Okay, so whenever we talk about common time, this is where, okay, we need to use one of the hits here for LCM. Okay, I can see Lucas saying, correct. It is actually LCM. So earlier, this is what I like to call, for question number 2, is what I call the grouping questions, where questions will actually group the different items together. So when it's grouping, that's when it's actually HCF. Okay, but when it comes to the common time, yes, it is LCM. Okay, so over here, all right, they say how many more times in a day will the trains enter the station together? So step number 1, we need to find LCM. But now you guys may be wondering, LCM of what though? So let's take a look at the question. Okay, they already told us that there is 12 minutes, 21 minutes, and half an hour respectively. So we can pretty much use all of this and find the LCM of each of the timings. So please remember, half an hour. Okay, do you guys know what is half an hour? You guys learned this in primary 4. So to convert from time to minutes, half an hour is 30 minutes. So our job is to now find the LCM of these three numbers. Okay, so find the LCM of 12, 21, and 30. All right, so using the prime factorization, which we did earlier, okay, so I'm going to show you what is the prime factorization. So for 12, it's 2 squared times 3. Okay, for 21, it's 3 times 7. All right, and then for 30, it will be 2 times 3 times 5. All right, so once again, I have pretty much cut short the prime factorization portion because it's too straightforward already. Okay, so pretty much we get this. And now, how do we find the LCM? Once again, we find the largest power. So I'll write down over here. We'll choose largest power. Okay, so let's choose the largest power for all of these three. So I'll write down LCM. So let's take a look. LCM for the first one. The first number that we see over here is the number 2. So 2 square 2. Alamak, in the middle don't have any 2 guys. So what I did just now, if don't have the number 2 in the middle, I will add 2 power 0. So I'll write down 2 power 0. Then I compare. Okay, so now I choose the highest power, right? So the highest power will be 2 squared. Okay, and we can do the same thing for the other numbers as well. So let's try for number 3. So 3 on top, 3 and 3. Okay, I think this is the easiest because they all have the same power. So I can't really choose a higher power, right? So we'll just write down 3. You can choose any of the following. And let's do the same for 5. So now I got 5 at the bottom. Ayun, middle and on top no 5 guys. So I can add my 5. So 5 power 0, 5 power 0. So I will look at this tree and the largest power will just be 5. Okay, and we can do the same thing for 7. Okay, and the largest power will be just 7. And when I add all or multiply all of this together, okay, you will get 420. So what does this 420 mean? Please write down your units. Okay, so 420 means is 420 minutes. Okay, so what this means is that every 420 minutes, okay, the 3 trains will meet. But now the question asks, how many more times in a day will the trains actually enter the station in a day? So in one particular day. So let's think. Over here, did they mention what time the train station start? They say it's from 7:30 a.m. to 11 p.m. So let's find out how many hours is that actually. So 7:30 a.m. to 11 p.m. So I'll do the quick math for you. Okay, for 7:30 a.m. to 11 p.m. is about 15 and a half hours. Okay, 15 and a half hours. All right, so since you already know that it's 15 and a half hours, what you're going to do is I will convert this 15 and a half hours into minutes. So I will times 60. Okay, then I will get 930 minutes. Now, since I know that in a day, there is this 930 minutes where they will actually, that the whole station is functioning in that period of time, right? So how do I know how many more times you will meet? I will take 930 divide by the 420. Okay, so when I divide it like that, I will get, I think, a decimal of 2.21, blah, 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 blah. So when I round off my answer, I will just write down that it's about 2 more times. That's it. Okay, so those are the steps that we take when it comes to using or solving this kind of question over here. Okay, so that is for question number 3. Okay, so let's take a look at question number 4. So let me see. Question number 4 over here. So for question 4a, I think it's pretty straightforward. So I'm going to quickly go through this 4a here. So for 4a, you have to write to how many dp. So over here, it's completely up to you. You can, because the question is specified, I would say to be safe, you write to 2 dp first. But in your exams, I would say just be careful because in this kind of question, okay, they didn't specify. So they asked for how many more times. So in your final answer, you can't really leave it in any decimal place. You need to choose a whole number. So which is why I chose the number 2. Okay, next, we take a look at question 4. So for 4 over here, 3528. Okay, so wait, can I write 420 divided by 60 and 50 and a half divide by 7? 420 divided by 60. Okay, why do you do that, Geraldine? Why do you divide by 60? Okay, hold on. While you're answering that, let me quickly go through question 4 here. So for written, or over here they say written as a product of its prime factors, 3528 equals to 2 cubed times 3a times 7 to the power of b. So what we're going to do first is we figure out how to express 3528 in terms of the product of its prime factors. So you can use the ladder method, you can use the, what's it called, the calculator method as well. Okay, and then you will realize that 3528, okay, equals to 2 cubed times 3 square times 7 squared. Okay, and when we compare, we can easily see that A equals to 2 and B equals to 2. Okay, next. Over here at the bottom, okay, they say that find the smallest possible or positive integer values of x and y such that 3528y over 2 to the power of x times 5 is a perfect square. So perfect square is where you should remember that the powers must be a multiple of something. So what is this something? If you guys already forgot, okay, you guys can write down with me over here. Powers are multiples of 2. Okay, that's what perfect square means. Okay, so over here, let's take a look. 3528. Ayo, what is this 3528, guys? Let's express it as a prime factorization first as well. So I've got 3528. We already found the prime factorization. So let's just write it down over here. So 2 cubed times 3 square times 7 square. And then we know it's times y over, now this 2 to the power of x times 5. So our job is to actually make the powers be multiples of 2. So over here, the powers, if you realize, right, the powers, some of them are multiples of 2, but some are not. So what we need to do is, using this y and using this x, let's make them powers of 2. Okay, so we take a look over here. So let's focus on 2 first. So when I compare 2 cubed and 2 to the power of x, since 2 cubed is divided by 2 power x, right? This means that my x must actually be bringing 2 power x down. So over here, I'll write down here. So 2 power 3. Okay, we will make it go down to become 2 power 2. Okay, so for it to go down, I need to divide it by 2. So when I'm dividing it by 2, let's see. 2 is to the power of 1, which means my x equals to 1. So x is pretty much this power over here. Okay, now, how about y? So let's see. Actually, right, guys, maybe a lot of you guys may be wondering, hey, Mr. Hassan, if I make the 2 become 2 square, right? Technically, all of my powers, if you take a look, all my powers are really multiples of 2. What? Why do I even need to have y for? So this is where your y actually is, I would say it's a distraction, but it's because of another number that we see in this question here. this annoying little number 5 here. What is this 5 doing here, guys? This 5 is not doing anything here at all. So this y, what it's trying to do is maybe it's trying to help us to get rid of another number that is not part of this product over here. So what is this other number? It's actually this number 5. This number 5 over here, correct. It is used to remove the number 5. Okay, so what we're going to do here is the y. Okay, if this is a 5, okay, so if this equals to 5, what happens here is it will be cancel out from each other. Okay, so my y actually equals to 5. Okay, so you say is times 1 or 2? Times 1 or 2? What thing times 1 or 2? Are you talking about this one here? This power 1, is it? Is that what you're referring to? Alamak, you say 1 times 1 times 1. Okay, get out. Okay, enough, guys. Okay, the chat is going a bit wild. Okay, so please relax. Okay, the main focus here is not the chat, is to focus on the content here as well. Okay, so that is for question number 4 here. So let's take a look at question number 5. So for question 5, I would say A and B, right, is very straightforward. A and B, I would say, is not the main problem that I want to work towards actually. It will be part C. So for part A and B, I will quickly go through it with you guys. Okay, so 180 as a product of its prime factors, I think pretty simple. We can easily calculate it. So 180 will be equivalent to 2 square times 3 square times 5. Okay, and when they ask to find the highest common factor between these two, okay, so once again, highest common factor means I choose the smallest power. So if I want to choose the smallest power, what I need to do is I need to compare the two products. So I've got 180 is 2 square times 3 square times 5, and 2646 is equivalent to 2 times 3 cube times 7 square. Okay, so over here, we've done the HCF earlier on, right? So I'm going to leave you guys to try and find out what the HCF is. So eventually, your HCF should look something like this. 2 times 3 squared times 7 power 0 times 5 power 0, which equals to 18. Okay, so that is for part B. And then now for part C, okay, so over here, it is given that 2646. Okay, I think there's a printing error in your worksheets. Okay, so if you take a look, I think they put there 2646 only. So remember to add in a k over there. Okay, it's a perfect square where k is a positive integer. Find the smallest integer k. So this is a very common question where they want you to convert 2646 into a perfect square. So remember, the powers must be multiples of 2. Okay, so powers are multiples of 2. So now that the powers are multiples of 2, let's see. I got 2646, right? So let me just quickly write down the product of prime factorization. So I've got 2 times 3 cubed times 7 square. All right, so over here, I got the 2. Ayo, the 2 is power 1. It's not a multiple of 2, right? So what do I need to do? I need to increase it, okay, to a 2 to the power of 2. So what must I do? I must times 2. Okay, and similarly, for the 3 cube, ayo, not a multiple of 2, guys. So what must I do? Make it into a power 4. So 3 power 4. So this means I need to times 3. And then 7 power 2, okay lah, 7 power 2, I would say it's already a multiple of 2. So I don't need to change the power. So now they're asking us what will the value of k be? So k is something I changed. I added to change my 2646. So what is it that I changed? Is this 2 over here? So k is equivalent to 2 times 3, which equals to 6. And I think somebody wrote down 6 earlier. I think it was Jared, is it? I saw somebody writing 6. Okay, so yes, correct. Yes, Jared, yes, it's 6. Okay, good. So that is the answer for this question here. Okay, next up, let's take a look at, okay, I hope you guys are able to copy down. If you guys can copy down, okay, don't worry. Later at the end of class, you guys can stay back, okay, and ask me to show you the question, okay? Jared say, holy speed run. Yes, I know, right? Because 1.5 hours, right, is very short. Okay, so that's why I would say it's supposed to be very fast-paced going through the different portions here. Okay, so that is for question number 5. Okay, so for question 6, I'm going to leave it to you guys to try it because it's the exact same question. I purposely added this question over here just for you guys to recap. okay, at your own time after class and see whether you guys understand the concepts or not. Okay, but don't worry, I'll give you the answers. So for part B, the HCF will equal to 144. Okay, and for key over here, the value is 5. Okay, so the reason why, once again, okay, I'm letting you guys know why is it that we are not going through this is because this is a question that is supposed to help you from the previous part, okay, which is from question number 5. Okay, so yes, Jared say wait. What do you mean by wait? Yes, what happened, Jared? Shouldn't part B be LCM? Part B over here, they say is smallest whole number. Okay, so this is where some students will get tricked, okay, because they see the word smallest. Oh, smallest means LCM confirmed. So this is where you need to understand the whole question. So they say that it's divisible by both 720 and 1728. So divisible together with the word small means they are talking about HCF. Divisible means it can be divided. So what number can be divided by 720 and 1728, which means is HCF. So that's just something to take note as well. So that is for question number 6. Okay, for question 7 over here, okay, they asked to, okay, this one over here, I'll quickly go through it with you guys. All right, so for question 7, I would say it's a bit different, okay, where we have a times and a divide. Okay, but you see over here, wait, okay. Yes, wait. Okay, means I'm gonna assume is this question here. Didn't they ask for the smallest factor? Smallest factor? I think they asked for the smallest whole number, Justin. Yes. They asked for the smallest whole number. Okay, so isn't the answer technically the number 1? You're not wrong, but I would say because over here I think they want it to be a number that's not 1 lah. 144 can't be divided by 720. Okay, let's see. 144 can be divided by 720. Hey, that's pretty good, huh? Okay, so over here, let me check for you guys. Yeah, of course, 144 cannot be divided by 720. It should be the other way around. Okay, it should be 720 that can be divided by 144. So over here, the HCF is 144. So you are taking 720, divide with 144, not the other way around. Okay, can do now. I don't know how to. What do you mean? What do you mean I can do now? I don't know how to. Okay, so, you mean for part B here, but the smallest number divided by 720 and 1720. Yes. It's just the HCF. Don't worry. Yes, it's just a HCF. So, okay, so for Vincent, okay, if you don't know how to do, later at the end of class, okay, I will quickly go through it with you over here. I'll just put a star. I will come back to this. Okay. So let's take a look at for 5B. The answer for 5B is 18, Dylan. Okay, so that is for question 6. So now let's take a look at question 7. Okay, so don't worry. Okay, if there's any question that you guys don't know, okay, at the end of class, I won't just disappear. Okay, I will still be here, okay, to answer some questions. So let's take a look at question 7. So express 576 as a product of its prime factors. So over here, pretty straightforward. Okay, another person asked, can I see 6C? Okay, last one. 6C is 5. Okay, and that is it. Okay, so let's take a look at question 7. So any questions later? Okay, hold on. Okay, Melody, yes. May I ask what is the answer for question 4? Okay, later on, Melody, I will show you the answer, okay? All right, don't worry. I will definitely show you guys. All right. So for question 7A, express 576 as a product of its prime factors. So once again, product of prime factors question, I won't take too long. Okay, I will, you guys have, I would say, already know the steps for this. So I will show you, I will let you know that it's 2 to the power of 6 times 3 squared. Okay, and then next, for part B, using your answer in A, explain why 576 is a perfect square. So this is where you have to use a bit of words as well to explain your answer. So over here, when we talk about perfect square, we mentioned earlier that the powers must be multiples of, let me see, somebody type in the chat. Not supposed to be multiples of what? Multiples of 2. Okay, so over here, we take a look. For 576, both the powers are multiples of 2, which means it is a perfect square. So we write down over here that powers of 576 prime factorization are multiples of 2. Okay, thus it is a perfect square. Okay, so that is for question 7a and b here. So for part C, okay, given that m and n are non-zero whole numbers, find the values of m and n such that 576 times m over n is a perfect cube. Oh my goodness, I forgot to tell you guys about part C as well. I wanted to tell you guys at the start of class that we wanted to play a game where I wanted you guys to tell me what's it called, what is wrong with some of the questions, because I purposely left out to see whether you guys were paying attention, but I forgot to play the game with you guys at the start. Okay, never mind. So I'll just show you for part C over here. Okay, given an m and n over here, you just need to include that. Okay, they are is a perfect cube. So 576 times m over n is a perfect cube. So what we're gonna do here is, okay, for it to be a perfect cube. Perfect cube means the powers must be multiples of 3. Okay, so over here right now, powers are multiples of 3. Okay, so it's supposed to be R, not RE. Yes, indeed, correct. It's supposed to be R. Okay, so over here, we want the powers to be multiples of 3. So let's write down the 576 first in terms of the prime factorization. So 576 is the same as 2 power 6 times 3 squared. Okay, and now they say that I want to times m over n. So if I want to times m over n, okay, let's take a look at what happens. So times m over n. So m is gonna multiply to 576 while n is gonna divide, which means one of the powers is gonna increase and the other powers must decrease. So let's see. Since I want it to be multiples of 3, right? So let's take a look over here. I would say, okay, 3 square is the only one that is not what's it called, a multiple of 3 in terms of the power. So what we can do is we can increase the value, okay, to be 3 to the power of 3. Okay, so 3 power 3. Okay, yes, Justin, you raise your hand. You can type your question in the chat as well. Okay, so yes, correct. So 3 power 3 means I must times 3. Okay, then over here at the bottom, m over n. What could n be? Because n technically, we don't really need to change it, right? So guys, this is where it's sort of like a trick question. So n over here, okay, because 2 power 6, 6 is already a multiple of 3. So n, I do need to multiply with anything. N will just be 1. So m will equals to 3, while n will equals to 1. But then, is it right to say that there are many values for what m and n is? Oh, definitely. There are plenty of values. Like m can be 6. M can be 6, correct. So that's why for some of these questions, sometimes there could be a range of values. But I think sometimes in the question, they will either specify whether it's the smallest number, largest number. So over here, the question didn't specify by the school. So that's why I would say try to make your answers as either, okay, I wouldn't say too small or too big lah, but like directly the closest answer lah. Okay, so yeah, so over here, okay, the m value will be 3, while the n value will be 1. All right, so that is for this question C over here. Okay, so I hope you guys are writing as well. As much as you guys are typing, you guys are writing your answers. Okay, so now we are going to take a look at question number 8. So for question 8 is actually a recap for question number, what question was it? The one about the train one. I think it was question number 3. Yes, question number 3. So question number 8 is just a recap for you guys to try. So over here, okay, let me quickly see. Okay, I think this question we can quickly go through in class as well, because I think, yeah, over here, I think this is very straightforward, this kind of question. So over here, we got 2 platforms once again, okay, in a train station. So the train on platform A enter the train station every 12 minutes, while for B enters every 21 minutes. And then they say, when is it that the trains will enter together again? Easy peasy. Together again means we are talking about common time. So I want you guys to write down at the corner here, common time. Okay, and guys, when we talk about common time, is it HCF or LCM? I know later somebody will definitely type in LCMMM. I think that was Lucas, I think. So let me write down here LCM. Okay, so all you need to do is to find, oh my gosh, Jared is the one that says it now. So for over here, we find the prime factorization first. So 12 minutes. Okay, the prime factorization will be 2 square times 3. While for 21, it will just be 3 times 7. Okay, so that's the, oh my goodness, wow, Lucas, wow, you're going ham with it. So yes, okay, that is for 12 and 21. So if I want to find the LCM, okay, I will choose the largest power. Okay, so since I'm choosing the largest power, okay, so my final answer will be 2 square times 3 times 7, okay, which equals to 84 minutes. All right. So now, if you want to find out what's the time, don't forget, they're asking for the time, not the time taken. So time means I want the exact time, which means it's 84 minutes. So 84 minutes is the same as how many hours? 84 minutes is 1 hour and 24 minutes. Okay, so 1 hour and 24 minutes after 7:30. Okay, so 7:30 plus 1 hour and 24 minutes. Okay, is what Jared said 8:24. Alamak, really man, 8:24. I think it's not 8:24, it's 8:54 because I plus 24 minutes. Okay, yes, Geraldine, correct. Okay, 8:54. Okay, next up. So for part B, okay, the train station operates daily from 7:30 to 9:30 daily. How many times a day will the train enter the station together? So this one, they already give you a range. So let's find out the time taken first. So 7:30 to 9:30. How many hours is this? This is about, oh, wow, who's this? Who's this type 10, 10, 10 all the time? Oh my goodness, Jared. Okay, please stop typing 10. Okay, yes, Geraldine, it is 14 hours. All right, so since it's 14 hours, we will find out how many minutes is this. So this is equivalent to 14 times 60, which equals to 840 minutes. Okay, let's just double check that. 14 times 60, yes, 840 minutes. So how many times will they pass by each other? So since I know that they each will pass by every 84 minutes, so what I will do is I will take 840 divide by 84, which means is 10 times. Okay, so, oh, sure, please go up a bit. Oh, you want me to go up? Okay, I'll go up. Okay, okay, I think you mean the paper go up. Yes, I will scroll upwards. Okay, so that's why sometimes I see what my students type, right? I also sometimes can laugh one. Sure, go up a bit. Wow, it make me sound like I should go up. Okay, but yes, I got what you mean, George. Yes. So I scroll up a bit for you, and yes, that is the answer for this question here. Okay, so in your WA, you are definitely going to be tested on this kind of questions over here, okay, where they ask you about the train lah, about when is the next time they will meet. So have a look at this question, understand, and please remember how to do the question, okay? So this is for question number 8. So I'm going to give you guys about a minute, okay, to go to, what's it called, write down the answer before we take a look at the next chapter. So we are done with what's that called? What's this called? Factors and multiples. Okay, so we are now gonna move on to chapter number 2, which is on real numbers. So if you realize, we've got about less than half an hour for real numbers. Oh my God, Lucas said, "Holy speed run!" Correct. My nickname is Speed Lucas. So not like the Twitch streamer Speed. Mine is the math speed. Okay, so I pretty much summarize up. Okay, the chapter on factors and multiples within about an hour. Okay, the things that your teacher did for, let's say, about maybe 4 weeks, 4 to 5 weeks. Okay, yes, we did it in 1 hour. So that's why it's a lot faster, more faster pace. So let's take a look at the next portion here. Okay, so for integers and real numbers, okay, you can take a look. I have summarized for you nicely all the different things that you need to remember for integers and real numbers. Okay, so you can take a look. Okay, what happens when we have addition of all these numbers? So don't worry. Okay. Oh my goodness, you put speed space there, Justin. Oh my gosh. Okay. So yes, for this kind of question, okay, let's move on to real numbers now. So some points that I want you guys to remember when it comes to addition and subtraction of negative numbers, positive numbers. I want you guys to remember that there's this analogy that I tell my students. When I have negative, I have positive. So example, when I have 7 plus -4. The analogy I teach my students is when we compare plus and minus, who is stronger? Minus is always stronger. So minus will be able to beat up plus. So since minus can beat up plus, right, means minus will win plus. So over here, I see I got plus, I got minus. So this is the same as 7 minus 4. Okay, and this is the same for any signs in math. All right, so another example, 7 minus negative 3. This time, right, wow, negative finally meet his match. I got a negative and then I got another negative. Now they're gonna fight each other. So what is this gonna happen? Or okay, what's gonna happen to the minus and minus? It will, oh, Alina say 10! Exclamation mark, exclamation mark, exclamation mark. Very good. Okay, yes, it will be 7 plus 3. Because the two negative signs, because they realize that they are both equally powerful. You know what they do, guys? They decided to combine forces and then become a plus, correct? Okay, so Justin said easy. Will this be on the YouTube channel? Most definitely, it will be on YouTube. Okay, for you guys to watch as well at the end, at your own time. All right. So that is the summary over here. So of course we have multiplication and division. It's the same logic. So example, when I have negative 7 times 3, what's going to happen to the negative sign? So this time, negative sign and positive sign. So negative 7 and positive 3. Negative and positive, who will win? Definitely negative. So it will be negative, and then I take 7 times 3, 21. Ta-da! I have my answer already. So this analogy, I teach it to all my students and they are able to get through this. Okay, so that is for addition and subtraction of negative numbers and positive numbers. Then for multiplication, I think this one you already learned in primary 6 already. So please, at your own time, have a look at what this whole portion is about. Okay, very straightforward. Add and subtract a bit hard. Okay, yes, I do agree. It can be a bit more challenging. Okay, because all you need to do is to make sure they have a common denominator. So when I add and subtract my fractions, please remember that I must make the denominator the same, then I will add and subtract. Okay, so I hope that is something that you guys can, I would say, take away from today as well. And then of course we have rational numbers and irrational numbers. So this question as well, I can guarantee confirm coming out already. I got a saying, don't work hard, work smart. Yes, correct, Justin. I also do that as well. Okay, so anyways, so rational numbers means the numbers can be expressed as a fractions, while irrational numbers cannot be expressed as a fraction. Okay, so that is for this portion over here. So now we shall take a look at some questions here. So let's start with question number 1. Okay, so question 1, a weather station is situated at 8,000 meters above sea level. At one time during wet weather, the temperature recorded by the weather station was negative 17 degrees. My goodness, it's so cold. When the temperature at the sea level was 31 degrees Celsius. So calculate the differences between the two temperatures. So when I talk about differences, means I must take the larger number minus the smaller number. Okay, the people arguing on the chat, right? Yo, please lah, enough lah. Work both hard and smart. Okay, yes, whatever it is, whatever it is. Let's zoom into whatever we're supposed to do here. Okay, I see you guys arguing like what's it called, like boyfriend, girlfriend, like that. Okay, so enough. So anyways, over here, let's take a look at the difference. So when we talk about difference, means I'm taking the larger number minus the smaller number. So between 31 and negative 17, which is the larger number? Okay, it's gonna be 31. So 31 degrees Celsius. Now I must minus the small number. That's what difference means. It means it's minus, right? So I minus. Now the mistake that a lot of students do is that they put minus 17. Oh my goodness. Okay, please, why don't put minus 17 like that? It's supposed to be minus negative 17. You are subtracting the two numbers here. I'm not just leaving the negative in the middle. No. Okay, so I subtract means I will minus, and then now I got minus and minus, they will combine forces and become a plus. So 31 degrees Celsius plus 17 degrees Celsius, and this will become 48 degrees Celsius. Okay, easy peasy. All right, so okay, so the people on chat, okay, I can see you guys are suddenly talking what? Plus today Valentine's Day. Alamak, again, why are you suddenly talking about Valentine's Day? And yesterday was Friday the 13th. Oh my goodness. Suddenly distracted by Friday the 13th. Okay, so enough. So let's take a look at part 1 here. So this time, if the temperature decreases constantly with increasing altitude, calculate the temperature at 5,500 meters above sea level. So when they say that it's decreasing constantly with increasing altitude, means the temperature is going down, and when the temperature is going down, means it's going down at the same rate. So what we need to do here is, okay, since I know that the height, okay, of the weather station is 8,000 meters. So example, I'll draw it out. Weather station is up here. This is 8,000 meter. Okay, so that is the mountain that I'm drawing over here. So since it's 8,000 meters, they say that at every meter it's decreasing bit by bit. So since I know the total temperature difference, and the temperature over here is, I think it's how much? 31 degrees Celsius. And then at the top is negative 17 degrees Celsius. So they want us to find out what's the temperature at, let's say here, which is 5500 meters. So what I'm going to do is I'm going to find out every meter, how much does it decrease by. So since I know the total temperature difference is 48, we will divide it by 8,000 so that I know every meter what's the change in temperature. So when I calculate this out, I'll get 0.006 degrees Celsius per meter. So for every 1 meter, the temperature decreased by 0.006. Okay, but now we see that the temperature, we want to find out the temperature at 5,500 meters above sea level. So 5,500 meters above sea level is pretty much this height here. So I want to find out what's the temperature at this particular point. So first, I will take 5500 times 0.006. Okay, over here, this is what, when I calculate, I will be able to get 33 degrees Celsius. But is this the temperature itself? Okay, no, this is the temperature of it decreasing it by. So it will decrease from 31 degrees and it will decrease by 33 degrees Celsius. So why is it I put minus? Because it's decreasing. Now, this is what I call the difference. So it will keep decreasing for 33 degrees Celsius until we reach the top point. So now, how do I get the temperature at the top itself? Okay, or at 5,500 meters, I will take 31 degrees Celsius minus 33 degrees Celsius. And this will get me negative 2 degrees Celsius. So in this kind of questions, you have to pay close attention to the wording itself. So I think a lot of my students, they always get this kind of question wrong, right? Because they don't understand the question itself. So please try and understand the question first, then we proceed. Okay, so now next for question number 2. Okay, so they asked to write the numbers in order of size, starting with smallest. Okay, so can I see 1A? Okay, yes, 1A is over here on top. Okay, so can you see 1A? I hope you can. So for question number 2, okay, question number 2, right? If you see this in your exam, you should thank your math teachers because this kind of question are the easiest form of question that can come out in your exams. Okay, so every single time you see questions where they ask you to order the numbers, right? Starting from smallest or the biggest. Step number 1, convert everything into decimal because when you see decimal numbers, your brain, right, I would say can think faster. One. Okay, for me, Mr. Hassan, I hate fractions. I hate what's it called? Mixed number. I love to see decimal. When I see decimal, I can easily figure out if the number is bigger or the number is smaller. So let's take a look at the numbers over here. So the first number that I have is minus 2/5/7. So type into the calculator, find out what is the decimal point. In your exams for your WA1, you are able to use a calculator. So please use them to your own advantage. Okay. So type this into the calculator, you'll get minus 2.7142, blah, 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 blah. Okay, I'll just put a dot, dot, dot. We'll do the same thing for the other numbers here. This will be minus 2.7604. And now, what does this dot actually mean for 7.6? This dot means that the number is recurring. Recurring means it's being repeated. So what number is being repeated? You take a look at where the dot is at. So the dot is above the number 6. Okay, so this means that the 7, it will be 0.6666 all the way until the end. Okay, and that is for 7.6 dot. And for the last one over here, square root 441. So typing into the calculator, I'll get 7.6116 and so on and so forth. Okay, so now that you already have your decimal points, right? Your life, oh wait, then if I don't see the dot, I am cooked. Most definitely. You are cooked, you are baked, you are everything, Justin. Okay, so please open your eyes, look at the dot. Okay, so the dot makes a huge difference, correct? Okay, George, oh my gosh. Okay, so anyways, that is for this one here. So now we already have our decimal points. What am I going to do? I'm going to just start with the smallest. So which number is the smallest? Remember, negative numbers are obviously the smallest one. Okay, so the negative numbers over here, let's see, I got negative 2.7142 and negative 2.7604. So I got some students, they will tell me, oh, Mr. Hassan, 2.742 is the smallest one. But sure not. Negative numbers work very differently. An example is negative 7 is smaller than negative 6. Okay, so over here, the larger the number, for example, negative 6, negative 7 is a larger number, but because it's negative, means it's even smaller. It's further left on the number line. So a trick that I teach my students is imagine a number line and then plant all your numbers on the number line. Okay, so the smallest number over here, it will be negative 7.6, negative 2.7604. So we'll start off with square root 7.62 like that, followed by negative 2, 5 over 7, followed by 7 point, oh no, not 7 point, followed by the cube root 441, okay, followed by 7.6 dot. And this should be your answer. Okay, so that is the answer for question number 2. All right, easy peasy. This question is very straightforward. The tip that I teach my students, convert everything to decimal, do your order, and don't forget, please, I got some of my students, I think they very funny. Okay, what they do is they forget that they need to write down the original fraction, original number. Don't write down your decimal in your final answer. All your answers should be in the original form. So next up, for question 3, okay, same thing. Okay, I've got the numbers over here. So step number 1, I will write down my numbers in decimal form. So this time, okay, Justin, I hope you're not cooked again, because over here it's 0.23 and then got 2 dot on top. So what does 2 dot on top mean? Means the two numbers will keep repeating, 2 3 2 3 2 3, on and on and on. All right, so that is for 0.23, and then negative 0.2. Oh, it's just negative 0.2. There's nothing else I can write down. I'll say if you want to write down negative 0.200, also can lah. I guess makes your number a bit nicer. And then 0.232 is the same. Negative 0.23 is the same as negative 0.230 lah. I guess if you want to add a 0 just for your own viewing. So now, when I want to write down from the smallest, so which number is the smallest? Look at your negative numbers first. So let's see which negative number is the smallest. I compare between negative 0.2 and negative 0.23. So the further left on the number line it is, the smaller it is. So the smallest number here will be negative 0.23, followed by negative 0.2, okay, followed by 0.232, and followed by 0.23 dot dot. That's it. Okay, so that's the answer for question number 3. Next, for question number 4, from the list of numbers. Oh, sorry, I lag at 2. Can I see? Okay, you copy down question number 3 first, George, and then later at the end, okay, we will do, I will show you the answer. Okay, so those of you who are not able to copy down, please stay back and let me know which questions to go through with you. Okay, so yeah. All right, so I have a lot. Okay, don't worry. Yes, George, stay back. I can go through. I can show you which questions you need. Okay, mass infection. Oh my goodness, Jared, what happened? Okay, so anyways, so let's take a look at question number 4. So this time they ask us, from the list of numbers above, list the rational numbers. So over here, guys, rational numbers means these are numbers that can be converted into fraction. Okay, hello Justin, you don't say shut up lah. Okay, please, please. Okay, don't, you guys are already sec 1. Okay, this one like my primary school students, they will say all this one. Okay, so please, Justin, already sec 1. Okay, act like sec 1. So rational numbers means they can be fractions. All right, so remember to write this down so that you remember what rational numbers are. So out of all these numbers, which number can be a fraction? Let's see. 2.7 can be a fraction or not? Okay, I think using your calculator, you definitely, what's it called? Can figure it out now. All right, so 2.7 can be a fraction. So I'll put a tick. Pi can be a fraction of, guys. If you type pi into your calculator, right, wow, you get a very, very long number. So indeed, you cannot make it into a fraction. Cube root 9. So use your calculator again. When you type into your calculator, you will get 2.08008 blah 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 blah. So once again, doesn't look like you can convert it into a fraction. Definitely not. 11 over 5, is it a fraction? I think it's the most obvious. It is already a fraction. So yes, it is a rational number. And lastly, 0.0043. Typing into the calculator can as well. Okay, so your rational numbers will be 2.7, 11 over 5, and 0.0043. Okay, so that's for question number 4. All right, so for question 5, okay, they say over here that the highest temperature recorded in London was 40 degrees Celsius in July 2022. The lowest temperature is -16. Find the difference. So this is just a recap of the earlier question, the first question that we did. Okay, when we talk about difference. So once again, difference, largest number minus the smallest number. So largest number over here, 40. So I write down 40. Subtract with the smallest number, which is -60. Okay, so once I already write this down, you can type it into the calculator or you can take it one step further. I got negative and negative becomes positive. Okay, so plus each other, it gets me 56. Ta-da! That's my answer over here. What is 2 squared? Huh? What is 2 squared? 2 squared is 4 lah. Yes, Justin. Why you randomly say that in the chat? Okay, so anyways, that is for question number 5. All right, so I'm going to give you guys about 5 seconds to write down the answer before I move on to the last 4 questions. Okay, so yes, I realize we're going to overrun a bit. Okay, so for those of you who need to go, I would say try to stay back for a bit more. You never give us 5 minutes break. I know, right, Dylan? I completely forgot about the 5 minutes break because I need to go through all of the questions. Okay, so I wanted to give you guys a 5 minutes break, but then I realized, if I give you guys a 5 minutes break, later, what if some of you guys disappear and never come back? So I decided to trick you guys. Okay, I decided to write down as many things as possible first, and then I'll see whether I'll give you guys a 5 minutes break. But unfortunately, I'm sorry, Dylan. I couldn't give you guys a 5 minutes break. I also never get my 5 minutes break to drink my water. So yeah. Okay, so it's okay. We shall persevere through. Okay, another 4 more questions, and then we're done. And then we're free. Okay, then you guys can celebrate Valentine's Day as well. Okay, with your family members. So let's take a look at question number 6. Okay, so question number 6. From the list above, write down all the prime numbers. So once again, do you remember what's your prime number? We learned this in the first chapter earlier. Prime numbers are numbers that can be divided by 1 or the number itself. Okay, so example of prime numbers will be 2, 3, 5, 7, 11, blah, 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 blah. Okay, you guys are expert in this already. So let's take a look. Number 6, is it a prime number? Okay, most definitely not. 6 is not a prime number. Number -4, not a prime number as well. Now, square root 25, students think that it's not a prime number, but ask yourself, square root 25 is actually equal to another number. Square root 25 actually equals to 5. And 5, like the 5 minutes break that I didn't give you guys, like what Dylan said, it is a prime number. Okay, so square root 25 is a prime number. And how about -7? Don't forget, prime numbers are only positive numbers. We cannot have negative numbers. So that's why our only prime number is square root 25. Okay, next. For part B, they asked to arrange the numbers in descending order. So descending order means it's from largest to smallest. So I'm going to write down here, largest to smallest. Okay, so what's the largest number? Obviously, it's going to be the positive number. So let's see which is the largest number. Out of all these numbers, I got 8.27, I got square root 25, I got 6. So the largest number here is 8.27. Okay, followed by 6, followed by square root 25, followed by -4, and lastly, -7. Okay, so that is the answer. So why is 8.27 with the recurring dots above 2 and 7 not a prime number? So prime numbers must be a whole number, Andrea. So it must be 2, 3, 5, 7, 9. 2, 3, 5, 7, 11, blah, blah. So if you realize, these are all whole numbers. 8.27, unfortunately, Andrea, it is not a whole number. It is a decimal point. So it can't be a whole number over here. It can't be a prime number. Oh, Timothy said adios. Oh my gosh. I guess Timothy has left us already. Okay, so yeah, that is for this portion here. So the last 2 questions, last 3 questions, hang in there, guys. We're about to finish already. So for question 7 here, okay, they ask us to find or arrange the number above in ascending order. So ascending means it's from smallest to biggest. So from smallest to biggest means what we're going to do is we will Okay, once again, express all of these numbers in terms of decimal point first. So type in your calculator what each of these value mean. Okay, so when I type into the calculator, the first one is negative 0.125. The second one is already in decimal, so we don't really need to do anything. Okay, then I've got negative square root 24 is the same as negative 4.8989. And the last one is 7.8947. Okay, so when I arrange them in ascending order, what I will get is I will just get, I will start with the smallest number. So the smallest number over here will be negative square root 24. Okay, followed by negative 1 over 2 cube, followed by 4.916 and 717 over 19. Okay, so that's for question 7. And then for question number 8. Okay, so the table shows the lowest temperature in Hokkaido in the month of December. Which date has the lowest temperature? Ayo, this kind of question, very easy. Okay, what we're going to do is lowest temperature means I find the smallest value. So which one is the smallest value? We'll see that on the 23rd December is negative 4. So this means that it is the lowest temperature. Okay, so I'll write down here 23rd December. All right, and then for B, find the difference between the temperatures of 20th and 22nd December. So 20th is 6, so I write down 6. 22nd is negative 3. So don't forget, guys, write down negative 3. So minus negative 3, which equals to 9 degrees Celsius. Okay, so Sahana said you haven't done yet. Okay, give me a bit of time. Okay, I will scroll up later, Sahana. Then after that, I will show you the answer. Is that okay? Okay, just copy this down first. And then I will show you the answer at the top. Okay, I will pretty much scroll after we are done with the portions here. Okay, for you guys to copy down. Okay, Sahana? All right, so yeah, just write down your answers first. And lastly, I think for question 9 is, I would say, the easiest, one of the easiest few questions. Why is a 23? Why is a 23? What do you mean? Why is a 23? Oh, because they asked for the lowest temperature. Lowest temperature means is the smallest value. So smallest value means is 23rd degrees, 23rd December. If that's what you are asking, George, I think. Okay, because I see your question. Oh, I think why is A23? Yes. Okay, because they asked for the lowest temperature. Okay, so yeah, lowest temperature. Oh, you see wrongly. Okay, correct. Okay, so that is for question 8. Then for question 9. Okay, once again, they ask for descending order. So descending order means I want the largest to smaller. So largest number over here, let's take a look. I got pi over 4. So once again, use your calculator. Type in and find out what's the decimal point. 0.78539. Okay, in the decimal. Okay, then next, square root 3 over 2. In decimal form is 0.86602, blah, blah, blah. 0.75%. Using your calculator, you know that is 0.0075. And 3 over 5 is 0.6. And the last one is already in decimal form. So we're good to go. Okay, and next, we want to find the largest number first. So the largest number over here, okay, it will be, let's take a look. Largest number of all of this will be 0.8666. So it will just be square root 3 over 2. Okay, followed by the next one. Let's see. I'm gonna go with pi over 4. And after pi over 4, it will be 3 over 5. Followed by the next smallest is 0.57. And the last one will be 0.75%. Okay, and that is the workshop actually done. Okay, so for those of you guys who are here, I would say congratulations for surviving 1 hour and 40 minutes with me. Yes, that was super duper fast. My brain, I was talking and yapping so fast that we got here already. Okay, so congratulations for surviving. I would say if you guys enjoy the class, okay, my classes are still available if you guys are interested to join for our classes as well, because I would say the 1.5 hour session is definitely not enough. what I usually do with my students from week to week is these practices as well. So if you guys feel like the practices are very useful for you guys, okay, you can sign up for my classes as well. Okay, and then yeah, then I guess if you guys were to sign up and see me in class, then please let me know that you are the student who was in from the WA1 revision. Okay, then at least I know where you guys are from. And then oh my gosh, wow, what is this? We are done finally. Yes, Lucas. I can see Lucas is the most happy after we are done with this. Okay, so yes, thank you guys for surviving with me as well. Okay, so now I will show you guys the answers. Okay, so okay, I got some requests. Can you show me 4B, 5C, 8B, and the second one, 2 and 7? Okay, okay, hold on. Okay, I know everyone will send the messages, right? So I will go all the way to the top. Okay, so let's see question one. Anybody wants question one? Okay, now I doing. Oh, okay. I got so many. Okay, what's this? By okay. So if you guys are done, okay. Once you guys are what's it called? Done copying everything, then you guys can make your way out of the class. Hope to see you guys for my future what's it called classes as well. Okay, so if there's any questions, let me know in the chat as well. But please don't ask me whether I'm married or not. For some reason, all of my Sec 1 classes, they always ask me that question. And then I told them I will only answer if I see you in real life. That's all I can say. Okay, but anyways, okay, so for factors and multiples, okay, this is question one. I will scroll to question number 2 and 3 here. Okay, so okay, I see question. Oh, I see a lot of question 2. Okay, question 7. Okay, bye bye, just Jesselini. All right, bye. See ya. All right, so I think question 6 and wait, what was it? Question 4, I think. Can we send the PDF? Of course, I can. Let me send you here. Okay, so let me see. Okay, what's the common question? Okay, so question 4B. Yes, 4B, I think for George. You can copy this down. Okay, thank you, Cher. Oh, Elena, no worries. Thanks for accompanying me here the past 1 hour and 40 minutes as well. Once you're done, yes, you can leave. Okay, so just remember that, yeah, please study hard for your WA1 as well. Good that you guys are already here. So please revise. And yes, I'll see you guys. All right, bye. See you guys. Okay, so no worries, Jared. Thanks for accompanying us with all the memes in the chat as well, Jared. Do you have the answer copy? Unfortunately, I don't have the answer key. Like, I mean, the answer key is what you see over here. Okay, so maybe if you need any one of the questions, I will be uploading this onto the chat. I mean, onto the YouTube channel. So you guys can of course take a look at the video on what's it called on the channel as well. And then yeah, you guys can also copy from there.